Hello, third graders. Today we are going to begin lesson 2 of unit 2 about forces in science. And today we are going to learn what are some types of forces. So please open your science books to page 88 and follow along with me. Let's read right here at the bottom of page 88. All motion is caused by forces. Changes in motion are caused by forces too. Forces affect everything this skateboarder is doing. By the end of this lesson, you'll be able to plan and conduct an investigation about balanced and unbalanced forces. Turn to page 89. Can you explain it? The indoor skydiver flies because of forces acting on her. A cushion of air pushes her up. The instructor applies force to adjust her position. So notice this says explore online. Let's click over and watch a short video about these indoor skydivers.
I think the iFly field trip not only presents the math and science, but once they learn this physics, they go actually in the tunnel and they experience it. And I think that by doing it that way, they'll remember it forever. STEM is an acronym for science, technology, engineering, and math. It's trying to encourage kids to stay interested in math and science careers. Instead of just approaching them as separate subjects, it's approaching it as a group of information that can be used in the real world. We talk a lot about terminal velocity, the different factors that affect terminal velocity, the things that you can change to change your terminal velocity, the things that are standard for everyone. Then we talk about the different objects that we have, about how they're going to fly in the tunnel. We actually let them throw the balls into the tunnel, and they really love that. Terminal velocity is when the force of gravity is equal to the force of drag, but with the water, there's also the force of surface tension. That's the size that has the strongest surface tension, and so the water wants to break up to that size and hold itself together. When we do the parachute activity, I usually make it a bit of a competition and hold 2 at a time and drop parachutes. Once they've done that, they move on to their flight class with a flight instructor, where they watch the safety video, they get suited up, and then they actually fly. They definitely enjoy the flying the most, but they love the ball demonstration. I think they enjoy learning about the engineering, how the wind tunnels develop through the years. One of the kids' favorite part is watching the teachers, or even better, is watching the principal fly.
All right, wouldn't you love to visit that indoor skydiving place and fly in a wind tunnel? Looks like so much fun. All right, let's go back, not there, right over here, and think about the question. Number 1 on page 89 says, look at the picture. Can you identify the forces pushing or pulling on the indoor skydiver? Are those forces balanced or unbalanced? So think about the forces that might be at work to help the indoor skydiver fly, and write your answer on the lines in your book. All right, let's move on to page 90, Exploration 1, Touchy Touchy. Follow along with me as I read. Pushing back. If you push or pull an object by touching it, you apply a contact force to it. When you use a contact force to push an object, the object pushes back. If you pull on an object, the object pulls you. Let's look at number 2, push play. Look at the picture. There are 4 pairs of contact forces. Label the forces by drawing arrows. So look at each one of these images and you are going to draw an arrow either pointing this direction or an arrow pointing this direction to show either a push or a pull. Number 3, write the correct answers from the word bank to complete the sentences. Push, pull, toward, away from. When you blank on an object, it moves farther blank you. When you blank on an object, it moves closer blank you. So use these words to fill in these blanks. Next, turn to page 91. Read along with me. Carefully balanced. Pairs of forces are either balanced or unbalanced. Balanced forces are the same size and strength, but act in opposite directions, so there is no motion. When one force is stronger than the other and the forces act in different directions, they are unbalanced forces. Let's look at number 4, tug of war. Look at the pictures. Draw an arrow showing the direction of the force in each picture. Let's read under the picture of the dogs playing tug of war. The dogs are evenly matched. They both pull with a force of 10. The X marks the center of the rope at the start. The rope hasn't moved even though both dogs are pulling. Now let's look at the picture of the horse and the dog playing tug of war. And read right here underneath. Now, one dog is playing tug of war with a big horse. The horse is stronger and pulls with a force of 40. The dog will be pulled over the X in the direction of the horse. Now let's read right here. You can add all the forces that push or pull an object. This sum is called net force. Remember, a sum is the number you get when you add numbers together. If the animals pull with equal force, the forces are balanced. This is 0 net force. The motion does not change. Number 5, predict who will win and whether the forces are balanced or unbalanced. So down here in the table, we have force A, a big horse, and a big horse. We have force B, another big horse, or an adult elephant. So if you imagine a tug of war between a big horse and another big horse, who do you think will win? And is the force balanced or unbalanced? What about a tug of war between a big horse or an adult elephant? Who would win? And is the force balanced or unbalanced? In your evidence notebook, consider a big, strong bird and a small, weak bird pulling opposite ends of a stick to use in a nest. Use evidence to predict which bird will get the stick and tell why you think so. When you're ready, turn to page 92. Funny car forces. A powerful force from the engine pushes these race cars down the track. The cars move so fast that the brakes alone can't stop them. To stop the motion before the cars run off the end of the track, another force needs to act on the cars too. Let's look at number 6. Stop it. Look at the pictures below. Describe how the forces acting on the cars change from balanced to unbalanced, or vice versa, meaning the other way around. Notice this says Explore Online. Let's click over and watch the video.
Forces acting on a car change from balanced to unbalanced when the car is speeding up, slowing down, or turning. When a car is motionless, forces are balanced.
All right, let's click back over and answer the questions. We need to describe how the forces acting on the cars change from balanced to unbalanced. The first picture says this car goes from not moving to moving very quickly. Describe how those forces are acting on the car and how it changes from balanced to unbalanced. On the next picture, it says a parachute rapidly, meaning very fast, slows this car down. What happens to the force? Write your answers on the lines beside the picture. When you're ready, turn to page 93. Do the math. Strong pull. Number 7. You can use math symbols to show balanced and unbalanced forces. There are 6 horses on this team. It takes a force of 80 or greater to move the farmer on the plow. A. Is the combined pulling force of all the horses greater than, less than, or equal to 80? B. Is the pulling force of a single horse greater than, less than, or equal to 10? C. Write a math sentence to show balanced forces for a team of 4 horses that cannot move the farmer and plow. And lastly, putting it together. What adds the force needed to slow and stop the speeding racer? Describe how the forces acting on the car change from unbalanced to balanced. So for number 8, we are going to look back at the race cars and think about what adds the force needed to slow and stop the speeding race car. So let's look at this picture in particular. What is stopping the speeding race car? Write your answer on the line at the bottom of page 93. And the tip over here says when forces are balanced, there is no motion. All right, guys, I hope you had fun with this science lesson, and turn this in when you are finished. Don't forget to add pictures of your work into the slides.